and we are going to start with the interactive learning process of the select topics of physics. The topic is thermal energy in daily life. First, we are going to introduce a little bit, saying that the microwave works with the specific heat of the material because of its technology allow us to manipulate more than with the fire. For example, in a stove, the stove just heats superficially, while the microwave works with the particles and movement of waves. Then we have the case number one, which I'm going to explain. Leslie Fonseca. And it's about two bananas, one complete, another in half. If we put both the same amount of time in the microwave with the same energy, we can say that the half is going to heat more than the complete because of the less space. The energy concentrates just in one place, while with the whole banana, the energy needs to go with all places, so it will heat less. Because of this, the whole banana is going to reach the thermal equilibrium faster with the environment because it has less energy to transfer than with the half banana.
Hello, my name is Fernanda and I'm going to explain you the case number 2 that talks about tomatoes. For this experiment, the things that we need is 2 tomatoes. One tomato should be complete, like this that I have here, and the other one should be cut in half, like this. And one dish to put the tomatoes, like this that I have here. And it is recommendable to use a ceramic dish for this experiment. The things that we need to do is only to heat for 30 seconds the complete tomato in the microwave and then the medium tomato. Then we need to place the 2 heated tomatoes in the plate, and then we need to use our 2 palms to touch at the same time the tomatoes and analyze the situation. Then I'm going to explain what things I observed when I did the experiment. The first thing is that the tomato that is cut in half relies more heat than the other one because the amount is less, so it takes less time to heat up. In the other hand, the complete tomato is bigger, so they need more time and more energy to realize more heat. The second thing that I observed in this experiment is that the whole tomato reaches thermal equilibrium first because it is less hot. I mean, her temperature did not change so much when I put in the microwave.
Well, my name is Karib Garcia Olivarria, and I'm going to talk about the case of the milk, the case number 3. So the materials that I used for this experiment were the milk, 2 cups of ceramic. I used also some metrical cups and some spoons. So for my experiment, I had 1 cup of milk with 200 milliliters and the other one with 50 milliliters. And I put both of them into the microwave for 15 seconds. Then I measured with my finger the temperature. So for the question 1, the cup with 50 milliliters of milk was the one that gained the most heat due to the fact that the heat was distributed faster and it had a smaller amount of liquid. On the other hand, the cup with the greater amount of milk was a bit hot, but its temperature was lower if we compare it with the other cup. In conclusion, the 15 milliliters milk gained heat faster. So for the question 2, the heat continues to be transferred until the temperature of the milk are equalized. When this stage is achieved, we can say that the substances are in thermal equilibrium. With this said, I think that the 200 milliliter cup will reach thermal equilibrium more quickly because it doesn't have as much temperature difference as the 15 milliliters one with environment.
Hello, my name is Maria Alberto Flores Mendez, and I'm going to explain case 4. In this case, we make a similar experiment of case 3, but instead of milk, we use water. And we use the same volume that we use in the case 3, a cup of 50 millimeters and a cup of 200 millimeters, and heat at the same time, 15 seconds each. The cup with the less volume got more heated than the one with a greater volume, making the one with 50 millimeters of volume the one that released more heat and the one with higher temperature. Because it's the same amount of time and the heat, both less the volume, the less time takes to the heat to distribute in the water. That also explains why the great amount of 200 millimeters of water take more time to the heat to distribute in the great amount of water, making the one that of 200 millimeters of volume the one that have the lowest temperature of both and the first ones to reach the thermal equilibrium. In conclusion, if we take heat as a form of energy that is transferred between systems or objects with different temperatures, then conduction is heat transfer through the stationary matter of physical contact. Heat transfer between the electric burner of a stove and the bottom of a pan is transferred by conduction, and the heat transfer by radiation occurs when microwaves, infrared radiation, visible light, or another form of electromagnetic radiation is emitted or absorbed.
Also, we think radiation is the fastest mode of heat transfer, while conduction is the slowest mode of heat transfer. And this is because radiation is caused by electromagnetic waves, while conduction involves particles which move at lower speed than the other one.
And in conclusion, it will heat less in the stove since it heats up superficially and the allotted time is minimal. Maybe we preheat the stove previously, it will be a little more or just as hot. The stove does not consider the specific heat of the material.
Well, thank you. And this was our experiment.